Okay, so this class is for some basic part of physics. First, I will just discuss about the time period of a simple pendulum. So this is the time period, this is the length of the pendulum, and this is the g, the acceleration due to gravity. So this relation is very important for class 9 students and then in the higher studies. Like this time period, the variables are the length of the pendulum and the g is acceleration due to gravity. Then you will be asked that what are the relation between the T, L and G. So you can see that T is proportional to root of L, right? So T directly proportional to the square root of the L of the simple pendulum. And one more time, T is proportional to inverse of 1 by G, right? So if G is increased, then T will be decreased, or if G is decreased, time period will be increased. So it's an inverse relation. Now if I am squaring both the sides, so T square will be equal to 4 pi square L by G. And from here, if you see that if we are drawing a graph between T square and L, so this will be a straight line, right? So this will be a straight line. So here you are getting question like what will be the relation between the T square and L. So this will be a linear relation. T square versus L is a straight line. So it will be like time period T square in y axis, L in the x axis. It will be a straight line. So what will be the value of this slope, right? So this slope will be T square by L. So if we know that T is equal to 2 pi L by G. So you can say that T square is equal to 4 pi square L by G, right? From here T square by L is equal to 4 pi square by G. So this 4 pi square by G is a constant and this is called the slope of this T square L graph, right? Now if they ask you a question like what will be the graph between the T and L, then that will be a non-linear graph. So if we are drawing, so T square proportional to L. Now T is proportional to root L. So this will be a non-linear graph. This is not a straight line. Okay. Now next, one more basic thing I want to discuss, that is the moment of the force. So moment, the symbol of moment is tau. So tau is equal to the cross product of R and F. So this is bit advanced. So that means the torque is the moment of the force. So if I am applying a force here, let's say this is the pivot point and this is the R. Now I am applying force here, F force, and this is the distance R. Then it will be a rotational vector, right? So there will be a turning effect of force or the rotational force, right? So this symbol is tau, the torque. So this is the vector quantity. So if you are pushing a door here, applying a force, the door will have a rotational motion, not the translatory motion, right? So it will be rotational motions here. Now, what you will see that RF, so or I can say tau is equal to RF sine theta, right? That means this angle theta is the angle between the distance and this force. So if this angle is perpendicular, the torque will be maximum. It will be maximum torque, right? So for class 8, we are having very basic things. The same formula is derived in a very easy way. That means torque is equal to just force into distance. Distance from the pivot point to the applied of force. Like if I have the system here, this is the fixed point, I am applying force here. If this is distance d, this is force, then torque will be d into F, right? Now what will be the unit of this? Unit of force is Newton, distance is meter, so this will be Newton meter. So moment of force, torque and turning effect of force, these three are same name. So this three are meaning the same thing, right? So in class 11 you will know to the torque, on class 10, class 8 you will only get the word the moment of the force, fine. So the unit is Newton meter and CGS unit it will be dyne centimeter. It will be dyne centimeter. So this is about the torque. Now next is the pressure, right? Okay. So what about the pressure? The basic formula of pressure is equal to thrust by area. Now what is thrust? Thrust is a force, acting perpendicular in a surface. Thrust means a force acting perpendicular in a surface. That's called thrust. Any force acting perpendicular in a plane, that's called thrust. Fine. So same like Thor. You know that Thor was applying the force vertically like this. In the movies, like Thor is giving the vertical force. So that's an example of the thrust. Okay. If you are giving a force like this, so this is a perpendicular force. That's called thrust. Now, so pressure is thrust by area. Okay. So in any case, suppose I am having a surface. If there is a weight here or mass here, puts mass is m, weight is mg, and this is acting on this area A. Then the pressure will be, mg by A. This will be the pressure at this point. Now, if this area, so you can see that pressure is inversely proportional to the area. Now, if you increase the area, the pressure will be decreased, and also if you decrease the area, pressure will be increased. Example is, suppose I am having a brick, so like this shape, okay, fine. So this is one area, so this can be placed like this one also. So contact area, this A2 and this A1. Here you can see that A2 is greater than A1. So in this case, if pressure is P1, here pressure is P2. So you can say that so for this one the pressure will be higher, because pressure is inversely proportional to with the area. So if I can able to reduce the area for the same weight, the pressure will be increasing. The example is the brick. If I am having a brick, or if I am having this this textbook, so the pressure will be lowest in these positions and pressure will be highest in this position, because in these positions what you can see, the area is reducing, so the pressure will be decreasing, increasing here. So now next example is the knife. Whenever you are cutting something, what happens that the cutting area, the area is very small, right? So whenever it is touching somewhere, the pressure is high. That's why whenever you are cutting something, the touch area is very small, so we can give the more pressure on an object, right? Now for your classes of we are more interested on the liquid pressure. So what is liquid pressure? Let's say we are having some amount of liquid, and this is the area where this liquid is giving the pressure. Fine. Then we are going to calculate the pressure here. So area is A, the height of this liquid is h. If the density of the liquid is rho, then what will be the volume of this this liquid? V is equal to height into area, right? Now what will be the mass of this liquid? M is equal to V into density. So mass will be equal to H A rho. Now what will be the weight acting downward? W is equal to mg. So weight will be equal to H A rho g, right? Now the pressure acting at this position will be P is equal to thrust by area. So thrust is weight by this area. So that's coming P is equal to H rho g, right? So P is equal to H rho g. Let me write here. Yes. So this is the liquid pressure. So liquid pressure depends on this height, the height of the liquid. So if you are increasing the height, liquid height here, the pressure will be increasing in this area, right? Now one more thing, that if this is the surface height, you are going deeper, your pressure will be increased, because at every point it will measure the liquid column. So once you are increasing the liquid column, the pressure will be increasing in the deep of the sea or any water content. So you are going more deep in a water content, your pressure will be increased. That's why in any water content, any dam, the bottom line there will be giving the thick wall, because at this zone the pressure is very high with respect to this zone, right? So at this zone the pressure will be higher than this zone. Okay. So this way you can calculate the pressure of a liquid. So liquid column means the height of the liquid in any water container. Fine. So this is about the liquid pressure. Now what will be the the unit of the pressure? Pressure will be unit of force by area, right? Or thrust by area. That means pressure unit will be Newton per meter square in SI, and CGS it will be 9 per centimeter square. So this is about pressure, and pressure is a scalar quantity, whereas force is a vector quantity, and this is an area. Area is a vector. Fine. So this is about pressure. Now one more thing I want to highlight here. What is upthrust? So upthrust means what happened that upthrust is an force which is coming from the in upward direction. Let's you are having a liquid. If you are having something floating here, it will receive an upthrust force. This is called force of buoyancy, buoyant force. So this force is acting upward from any liquid or any fluid. Like it may be the gaseous also. Example is the parachute, right? If you are having the parachute, what happened? The parachute is receiving the upward force coming from the atmosphere, atmospheric upward force. That's why we are safe whenever we are under a parachute. So our our whenever we are descending down, that will be very controlled manner by increasing the area of the parachute, right? So this upthrust force is valid for liquid and also for the gas state. Here we are interested in the liquid part. For liquid, we are getting an upward force, and if I am having in this object, this will receive the downward force. Now, what is the condition of floating? The upward force must be greater than equal to downward force. If this condition satisfied, then only object will float. Okay. So that's it for today. So I will connect in the next session. Thank you.